In the last video on substitution, it was kind of nice because in each of the problems we did, it just so happened there was a variable by itself already. It was already isolated, we just plugged it in, we were good to go. As you can probably imagine though, a lot of problems don't have a variable by itself all set in the problem. If you look at the example on the page there, none of these variables are already by themselves. Step one that we always kind of just glazed over in the last video was isolate a variable. So if you don't have a variable by itself, you need to make sure you get one by itself. And when you do that, you can choose any of your four variables and get them by itself. You can get this x by itself, you can get this y by itself, this x, or this y. It's totally up to you. Any variable that you choose will get you to the right answer. So, with that being said, sometimes there are smarter choices or ones that require less work than others. In order to kind of drive this point home, I want you guys to think about the substitution lion. So draw like a little lion right here. And picture this lion right here. He's really hungry, and he wants to eat a gazelle. So this lion over here is really hungry. He's looking for a gazelle. There are four to choose from. There's this x, this y, this x. He wants to get one of them all by itself and work the problem from there. Out of those four choices, you have to decide for yourself which one is going to be the easiest for me to work with. Lion's hungry, but he doesn't want to work very hard. Which gazelle would be the easiest to get by itself? And the answer to that is this x right here. Of the four variables, this one would take the least amount of work to actually get it by itself, because all you have to do is subtract the 3y and you're done. If you choose a different variable, you'll have to divide and stuff too. If I'm a lion right here, I'm going to attack this guy, this gazelle, because I know it's the easiest, the least amount of work. So once I've made my decision here, I want to get that x by itself. I'm going to take my equation, kind of ignore the top one for now, and I'm going to get my x by itself. So I subtract my 3y on both sides, and I get x equals negative 3y plus 2. Once you get to that point, it's like the other problems. That's the only difference. You had to get a variable by itself before you can go from there. So this is my substitute. I'm going to go ahead and toss him into the other equation for the x. X is getting replaced. You'll find with these problems that there's a lot going on in terms of different steps you have to do. But if you just kind of think about it as a whole process instead of trying to remember individual steps, it works out well. Got a variable by itself, toss it in the other equation, just like before. So now I have 6 times, in parentheses, negative 3y plus 2 plus 5y equals negative 14. Good news is there's no x's there. This is something we know how to solve pretty quickly. You distribute, and then we're going to combine like terms. You get negative 13y, subtract 12 from both sides. That's going to equal negative 26. You divide by negative 13, it looks like you get y equals 2. So, got a variable by itself, plugged in another equation, solve new equation, get y. We're not done though, because now we need to go back and get our x. But now that we know that y is 2, we can toss that in anywhere on the board, and we can solve for x. So I could plug it in here, I could plug it in here, here. Really anywhere is fine. The easiest spot to plug it in is actually my isolated equation here, because x is already by itself. You just toss it in and you're pretty much done. But you'll get the same answer no matter where you plug it in. I get negative 3 times 2 plus 2, and negative 6 plus 2 is going to be a negative 4. So my answer, x comma y, negative 4 comma 2 is my solution to this system. One more problem for this video. Same sort of deal. When you look at one of these problems here, ask yourself, if I was a lion, which gazelle would I go after? Which of those variables is going to require the least amount of effort to get by itself? And in this problem, the answer is this y right here. So I'm going to take that equation, and I'm going to isolate the y. So I'm going to subtract 9x from both sides. So I get negative y, don't forget about the negative sign, equals negative 9x minus 5. I do have to divide by a negative 1 here, but that's not a big deal. No fractions or anything, that just changes my signs. I get y equals 9x plus 5. So, y is getting tired in the basketball game. This is his sub right here. I'm going to toss this guy in for y in my other equation, right there. And I'm going to write out what I get. So I have 6x plus 2, but instead of writing y, I'm going to write 9x plus 5 equals negative 6, and I just have to solve this equation. So I get 6x plus 18x plus 10 equals negative 6, combining like terms, subtracting 10. On this one, I do not get a whole number. I end up getting negative 16 over 24, which is 0.6 repeating, I believe. And yeah, and if it's a repeating decimal like that, it's honestly better to keep it as a fraction. So negative 16 over 24 reduces. I'm going to reduce that to negative 2/3. Again, since the decimal didn't stop, it repeated, I just went ahead and left it as a fraction. Got my x though. Now all I have to do is plug it in and get y. Easiest place I see to do that is right over here, because y is already by itself. So I get y equals 9 times negative 2/3 plus 5. And that's negative 18 over 3, which is negative 6. And negative 6 plus 5, I end up getting y equals negative 1. So there's my y, there's my x. I'm going to write it as an ordered pair. I get negative 2/3 comma negative 1. And I am done with this problem.